Hi, I'm Donald Sinclair. I'm a science teacher with Great London Tutors, and today we're going to be looking at a few topics in chemistry. This is how to balance redox equations. As with balancing chemical equations, balancing redox half equations depends very much on the valency of the elements involved. Let's look at a simple example, the electrolysis of lead bromide. Lead bromide, when it becomes molten, is almost completely ionized. It turns into lead ions, which have a charge of 2+, and bromide ions, which have a charge of -1. When an electrical current is passed through it, the positive lead ions are attracted to the cathode, the negative electrode, and the negative bromide ions are attracted to the anode, the positive electrode. When they get there, they become neutral by either losing or gaining electrons. So losing electrons is oxidation, gaining electrons is reduction, hence redox, reduction, oxidation. A handy way to remember this is with the mnemonic oil rig. Oxidation is loss of electrons, reduction is gain of electrons. Redox half equations tells you what's happening at each electrode. So for example, at the cathode, where the positive lead ions are being turned into lead atoms. A lead ion comes along with a charge of +2. Now the negative cathode has an overabundance of electrons, that's why it's negative. And so the negative electrons are attracted towards the positive ion. So each lead ion gains 2 electrons. The 2 electrons neutralize the atom, so that it becomes a single lead atom instead. Now, the reason we need 2 electrons here is because it has a charge of +2. So whenever you're dealing with an ion which has a charge of greater than 1 or -1, you need to balance it by putting in the correct number of electrons. At the anode, where the negative bromide ions are being made into bromine gas, the following takes place. A negative bromine comes along, and because there's a deficit of electrons at the anode, which is why it's positive, the extra electron that the bromine ion is carrying passes into the electrode. So it loses that electron to form bromine gas. However, bromine gas is diatomic. That means it's a molecule made up of 2 bromine atoms. So we cannot just write bromine on its own. We need to write Br2 to indicate bromine gas. The problem with this is it's now unbalanced. We have 1 bromine here, 2 bromines here, which means we need to write it as 2 bromide ions. Still, to make it balanced, we need to put in the appropriate number of electrons. Since 2 bromide ions would require to lose 2 electrons overall, we put a 2 in front of the electron symbol as well. So 2 separate bromide ions lose an electron each to form a single bromine molecule consisting of 2 bromine atoms.